All right, so what we're looking at today is climates. All right, now there's a difference between climate and weather. Even though they're closely related, there's a difference about them. Climate is weather over a long period of time. So if you're talking about the snowstorm that happened yesterday, or a windstorm's going to happen a couple days from now, that's going to be weather because you're just talking about things over a short period of time. But if I was talking about, how much snow there's been on the ground on average over the past 100 years or so, you're looking at climate in that case. So the weather will change, quite a bit from day to day. Climate's more of a long period thing. All right, now just like weather, with climate, typically the thing you're probably most concerned about is what the temperature is and what the moisture is. So those are the two main things that we use to classify climates. All right. Now, water budgets we looked at a while ago. Water budgets kind of show you a mathematical model how water moves from one place to another. Now, part of the water budget we can use to figure out the climate type. All right. And the two parts of a water budget used to figure out the climate is, first off, the precipitation, and secondly, the potential evapotranspiration. Now remember, potential evapotranspiration, that's how much water could evaporate and transpirate. That's directly related to temperature. So the hotter it is outside, the bigger the value for potential evapotranspiration, or the hotter it is outside, the bigger the value of EP. So we use those two things and something called the PEP ratio to figure out what the climate is. So for climates, you have humid, subhumid, semi-arid, and arid, and that's determined by what their PEP ratio is. So I'll give you an example. Let's say I had two cities, city A and city B. And city A and city B both got the same amount of precipitation, right? Their precipitation was 40. Well, let's say city A was a cooler city, and as a result, the EP, the potential evapotranspiration, was less. City B was a warmer city, and as a result, the EP was bigger. Maybe the EP at city B was 60. All right. Now, we use that data to plug in the PEP ratio. So for city A, that'd be 40 divided by 30. For city B, that'd be 40 divided by 60. I solve that out. 40 divided by 30 works out to be 1.3. 40 divided by 60 works out to be 0.7. So now I can take those numbers and go to my chart here. Anything that's 1.2 or greater is a humid climate. That means that city A is a value of 1.3. That is humid. City B is at 0.7. 0.7 is between 0.4 and 0.8, so that's semi-arid. Arid's another word for dry. All right, so city B has a semi-arid or semi-dry climate. So this one's a humid climate, and that one's a fairly dry climate, even though they both got the same amount of rain. And the reason being is that with city B, even though they got the same amount of rain as city A, because it's warmer, more of that water could evaporate. So when it rains, a lot of that water just turns around and goes right back up in the air, so not very much water hangs around the surface. Whereas city B, it rains, not as much water is going back up in the air, so that means more water could soak into the ground and go into streams and lakes and things like that. So, the thing that determines whether it's wet or dry climate isn't just how much rain, it also depends on how much that water is going to evaporate to. So it's a combination of these two things which determines what kind of climate you're going to have right there. All right? So what we're going to look at for the rest of this is what are factors that determine either how much rain you get or what your temperature is going to be, your EP, because those are the two things that determine your climate type. First off, your latitude. All right. First off, your latitude. If I have a low latitude, what that means is I'm near the equator. If I have a high latitude, what that means is that I'm located near the poles. If I'm at the equator, I have higher temperatures. And the reason why I have higher temperatures is the closer you are to the equator, you have a larger angle of insolation. The sun is higher in the sky. We get more energy from the sun when it's hitting straight down on a 90-degree angle or close to a 90-degree angle. At high latitudes, which means you're near the poles, the sun's lower in the sky, and when the sun's rays come in at a lower angle, the energy gets spread out more and you don't get as much. So it's cooler when you have a lower angle of insolation. So your latitude plays a major role in your temperature. Right? Your latitude also plays a major role in how much moisture you get as well, because there's some latitudes on Earth that are consistently dry and other latitudes on Earth that are consistently moist. And the reason being is there's some latitudes where the air is normally rising, which is low pressure, and there's some areas where the air is normally sinking, which is high pressure. So at the equator and 60 degrees north and south, those are the latitudes at which the air is normally rising and it's wet. 30 degrees north and south, and the north and south pole, those are latitudes where the air is normally sinking, so it's pretty dry. Now you don't have to memorize those latitudes, because those are actually in your reference tables. On page 14, so this chart on page 14, your reference table, shows you where the wet latitudes are and where the dry latitudes are. So you can see at the equator, it has a wet latitude, and the reason why it's wet is because the air is rising. Same thing goes with 60 degrees north. It's a wet latitude because at that latitude the air is rising. 60 degrees south, it's a wet latitude because the air is rising. Right? And then at 30 degrees north, it's dry because the air is sinking. The sinking air is high pressure. 30 degrees south, the air is sinking, high pressure, dry conditions. North Pole, air sinking, dry conditions. South Pole, air sinking, dry conditions. Right? So on the Earth, what we have are at the equator, you have things like the Amazon rainforest and the Congo and stuff like that, places that get lots of rain. At 30 degrees north, you have places like the Sahara Desert, Saudi Arabia, places where it's extremely dry. So being at a dry latitude is one of the ways in which you can get a desert. All right, other things. Large bodies of water help stabilize temperature. All right. If you're next to a large body of water, you're said to have a marine climate. And what that translates into is cooler summers and warmer winters. So the temperatures don't change as much, so you have a smaller temperature range. Now the reason why that's true is because water has a very big specific heat. It takes a lot of energy to get added to water to make the temperature go up. So that means that in the summertime, the water's, because it takes a long time to heat up, it's going to keep you a little bit cooler in the summertime. But because it takes so much energy to get the temperature of the water up, when wintertime rolls around, it takes a long time for the water to lose that energy. So if you're by the water in that case, the water's going to keep you a little bit warmer. So if you live next to a large body of water, the water keeps you from getting too hot or too cold. So your temperatures don't fluctuate as much, right? So you have a smaller temperature range. Whereas if you live in the middle of a large landmass, away from the water, rocks have a much lower specific heat. That means it doesn't take very much energy to make the temperature go up, or it doesn't have to lose much energy to make the temperature go down. So the land heats up quickly and cools down quickly. And if you live in the middle of a large landmass, you're said to have a continental climate, which means you have very hot summers and very cold winters. So your temperatures fluctuate up and down quite a bit. So you have very large temperature ranges. Right? So in the middle of the continent, it gets really cold and really hot. If you're by the water, in the summer, it doesn't get that hot. In the winter, it doesn't get that cold. Now, another thing about large land masses is that they can also limit your available moisture. So perhaps you may have heard of the Gobi Desert. All right. The Gobi Desert is a desert that is in Asia. Now, the reason why the Gobi Desert is a desert is because it's just really far away from a water source. So the Gobi Desert is like right around there, all right? So you have to think, like, if you're right there in Asia, where's the air going to get moisture from, right? The Pacific Ocean's over here, but at this latitude, the winds are blowing that way, so this moisture is blowing that way. The Arctic Ocean up here is quite a ways away, and that's frozen a lot of the time. The Atlantic Ocean's like way, way over here. So the reason why the Gobi Desert's a desert is it's just so far away from any place for the air to get moisture from. So that's the second way you can get a desert, is that if you're just really far away from any moisture sources. All right, something that affects the moisture, storm tracks. Weather systems or storms hit some areas more often. All right, so hurricanes. The hurricanes that affect North America, where they originate from, is off the warm water off Africa right here. And hurricanes follow a set path. Hurricanes pretty much always move like this, and then once they get to around Florida, they'll either just keep on going straight and hit like the Gulf of Mexico area, or they'll get this far and start working their way up the coast. All right? But either way, they get to around this Florida area here. So a very large percentage of the rain that Florida gets throughout the year is a result of hurricanes. Even if Florida doesn't get hit directly by a hurricane, they still typically go in that general direction. So a lot of times you'll still get a fair amount of rain from it. So a lot of Florida's rain is a result of it being in the path of hurricanes. Or in the Northeast here, right? Most of the storms that happen up here in the Northeast, or happen here in North America, end up tracking towards the Northeast. So we get lots of storms and stuff up here in the Northeast because we're in certain storm tracks. So if you're near a storm track, so like this place in Africa right there, that doesn't get very much rain because the storms track this way, right? So the storms track away from Africa and go towards Florida. So what direction the storm tracks are can determine your rain quite a bit. All right, ocean currents. All right, ocean currents. If ocean water is coming from the equator, it brings warmer temperatures and higher moisture contents if you live by the ocean. If the ocean currents are coming from the poles, it's going to bring cooler temps to coastal areas. And using the same map, all right, what these arrows represent is these arrows represent ocean currents. It's the direction the ocean water goes. So if you notice, some of these arrows are solid arrows, some of these are hollow arrows. There's actually a key down here in the map, I'll just tell you what the key says. The solid arrows represent warm water. The hollow arrows represent cold water. And the reason why the solid arrows are warm water is because if you trace it back, this water is originating from the equator where the sun's higher in the sky, so it's getting more energy. So the warm water forms at the equator, and then the current brings it up like that. Whereas, like the East Greenland current, the water's coming from the North Pole, so it's bringing cold water down like that. Now, the currents, based on whether you're by a warm current or a cool current, can affect your climate quite a bit. And just to give you an example, like right here, there's a city right there in Canada called Churchill, which is about the same latitude as Dublin, Ireland, right? Now, in the winter, so they're at about the same latitude. That means they're getting about the same amount of energy from the sun. Now, in Dublin, in the wintertime, it doesn't really get that cold. They usually like in the 40s in the wintertime. And it doesn't really snow that much in Dublin either. It's kind of a big deal when it snows there. It snows once in a while, but not that often. All right, so that's in Ireland. Churchill, Alaska, or Churchill, Canada right there. All right, now Churchill's not that big of a community, but it's famous for something. People like to go there to see polar bears, all right? There's a lot of polar bears in Churchill, Canada, Manitoba, Canada. So obviously if it's polar bears, it's gotta be pretty cold. This is really cold over here. Even though they're they're at about the same latitude. So the reason why it's so much colder there than it is there, the primary reason is because if you look at the ocean currents that go by Ireland, it is a warm water ocean current. So the temperatures in Ireland are a lot warmer than they would be otherwise because it has lots of warm water going by it. All right? So if you're by a warm water current, you're going to have warmer temperatures than you would otherwise. If you're by a cooler water current, you're going to have colder temperatures than you would otherwise. All right, elevation. All right, elevation affects your temperatures. The higher in elevation you are, the colder it is outside. When people go to hike Mount Everest, they don't go up in shorts and a t-shirt. They have like all sorts of winter jackets and stuff like that. So the higher you go up in elevation, the colder it gets. There's some places near the equator where there's glaciers. And the reason why you can have glaciers near the equator is because there's mountains near the equator, and if you go high enough up in elevation, even though you're at the equator, if you're high enough up, it's still going to be cold up there. So the higher the elevation, the lower the temperatures. And lastly, the mountains' effect on climate. When wind hits a mountain, the wind doesn't just stop there. The wind goes up and over the mountain like that. The side the wind hits, we call the windward side. When the wind hits the mountain, the air is rising. Whenever the air rises, it cools and expands. It eventually reaches a dew point temperature, which gives you clouds and rain. So on the windward side of the mountain, it's going to be very, very rainy and wet and cool. Air goes over the top of the mountain, and now it's sinking on that side. Sinking air compresses and heats up. Also, it lost a lot of its moisture back there. So on the leeward side of the mountain, it's typically quite warm and dry, right? And that's the third way that you can get deserts, is if you are on the leeward side of a mountain, right? So again, the thing that determines your climate is precipitation and temperature, or EP, and these are just a whole bunch of things that can cause your temperature, or have an effect on your temperature and your moisture, all right? So that is climate.